On a clear Saturday morning, Aisha laced up her sneakers and wrinkled her nose as a rotten egg smell drifted from the Little Willow River 2 blocks away, a sign of low oxygen and decaying algae from nutrient pollution. She had walked past it 100 times, but today she noticed crushed soda bottles, fast food wrappers tangled in reeds, and a persistent oily sheen near the storm drain.
Aisha, it used to look pretty here. What happened? Grandma, places need people who care. Maybe today is your turn.
At school on Thursday, Ms. Flores had taped a poster to the board: Community River Day, Science and Cleanup. She explained that the class would collect water samples, identify pollution sources, and help remove litter. The event was organized with the town's Environmental Services Department after students noticed river pollution in their local ecosystems unit.
Ms. Flores, science isn't just in books. Saturday, we'll be citizen scientists, testing water and tracking pollution sources. Leo, do scientists get pizza after? Ms. Flores, if we work like a great team, I don't see why not.
Families gathered by the river. Park Ranger Maya set out reusable buckets, nitrile gloves, litter grabbers, and EPA-approved water testing kits. City environmental specialist Jamal pointed at a storm drain labeled "Drains to River" with an arrow.
Ranger Maya, safety first, gloves on, closed-toe shoes only, and absolutely no entering the water. Hidden debris and unstable banks are hazards. Jamal, this storm drain carries street runoff straight to the river. Oil from cars, fertilizer from lawns, and litter get washed here during rain. We can't filter it. It flows untreated. Aisha, so even a dropped straw can float into the river? Jamal, exactly. And plastic breaks into microplastics that never disappear.
Ms. Flores opened a kit with digital pH meter, thermometer, and a turbidity tube, a clear tube with a black dot at the bottom. Aisha crouched beside her, excited but careful not to disturb sediment.
Ms. Flores, water temperature 18 degrees Celsius, warmer than ideal. Pavement runoff heats the river, harming fish. Aisha, the pH is 6.8. The guide says 6.5, 8.5 is safe for most life. Ms. Flores, good. Now turbidity. We fill this tube until we can't see the dot. 15 NTU, nephelometric turbidity units. Higher than healthy. Under 5 NTU. Cloudy water blocks sunlight for plants and clogs fish gills. Leo, why is it so cloudy? Ms. Flores, erosion from bare soil upstream and stirred up sediment from litter removal.
Ranger Maya showed the group a D-frame net and white sorting tray. After netting for 3 minutes in riffles, shallow, fast-moving areas, they poured river water into the tray. Tiny creatures wriggled like punctuation marks that had escaped a book.
Ranger Maya, these macroinvertebrates are pollution indicators. Sensitive bugs like mayflies mean cleaner water. Worms tubifex mean pollution. Aisha, I see a caddisfly larva. The chart says they tolerate mild pollution. Leo, and these wriggly worms. Ranger Maya, tubifex worms. They survive in low oxygen, polluted water. Finding them tells us we have work to do.
They walked the bank with clipboards mapping litter. Most trash clustered near the storm drain outlet and bus stop. Aisha sketched arrows showing how wind funnels wrappers from overflowing trash cans toward the river.
Aisha, trash isn't random. It collects where wind and water flow. We need bins at the bus stop. Ms. Flores, exactly. Science is using data to target solutions.
Cleanup began. Volunteers used grabbers to collect litter. They sorted into recycling, plastic, metal, general trash, and hazard. Needles, broken glass, handled only by trained city staff.
Leo, mostly chip bags and coffee cups. Light stuff that blows away. Aisha, this bottle says property of Riverfront Park. Someone left it here? Ranger Maya, never pick up syringes or chemicals. Flag them for the city crew. They have training and kits.
Near the bend, an old shopping cart was half buried in mud. Aisha stepped forward, but Ranger Maya raised a hand.
Aisha, we should pull it out. Ranger Maya, that cart could trap your foot if it shifts. The city crew has a winch for this. They'll remove it safely tomorrow. Jamal, safety isn't stopping us. It's how we keep helping long term.
They paused for lunch. Mr. Novak, a retired wastewater plant operator, sat with the kids.
Mr. Novak, when I started at the plant in 1975, raw sewage flowed here after heavy rain. The combined sewer overflow pipe was fixed in 1998. But now stormwater pollution is the bigger problem. Leo, what changed? Mr. Novak, more pavement means less soil to absorb rain. Oil, fertilizer, and litter wash straight into drains. But riparian buffers, like the plants we'll plant today, slow that down.
The group planted native sedges and willows, riparian buffer species, to stabilize soil. Aisha tucked roots into moist earth near the bank. No river water for planting, as it could spread invasive species.
Ranger Maya, these roots bind soil during floods, and they filter runoff before it hits the river. Aisha, so plants are like seatbelts for the riverbank. Ms. Flores, perfect metaphor. Let's buckle up this bend.
Before packing up, the kids presented findings. Aisha showed photos of tubifex worms and the litter hotspot map. Parents clapped as the class proposed solutions.
Aisha, pH was safe, but high turbidity and pollution-tolerant worms show stress. We need to stop trash at the bus stop and storm drain. Leo, we'll ask the city for a covered bin at the bus stop and only rain down the drain stencils for storm drains. Jamel, I'll submit your data to our watershed report and get those stencils approved.
Evening light turned the river bronze. The air smelled of damp earth and willow, not sewage. Ducks glided through a section cleared of litter. Aisha felt dirt under her nails and something bright in her chest.
Grandma, looks different already. Aisha, it does. Not fixed, but we took real steps. Ms. Flores, today's lesson? Aisha, real change starts with test the water, map the problem, then fix what you can.
So the lesson of the story is real change starts with understanding the problem scientifically, not just good intentions. Test the water, map the pollution sources, and fix specific actionable issues like storm drains or bus stop litter. Small data-driven steps create lasting impact where vague cleanups fail.